Season's greetings to all our viewers. You are welcome to this channel, African Science and Humanities Review channel. In today's episode, we want to continue with our discussion on the laws of science. We are starting by just introducing what science is, getting more details on what science is as a general field of study, what are the methods and the tools that are used in science. And then we're going to examine physics in particular. What are the various areas of physics? Because when you talk about the laws of science, in most cases, in many of the cases, we are going to be describing the laws of physics, because physics govern the general phenomenon that we live in. And then we are going to conclude by looking at engineering as an applied area of science. In preceding episode, we did not include engineering, but we just felt it is good to also look at engineering as an applied science. So we believe that you are going to enjoy today's episode. So please stay tuned and enjoy the episode. Thank you. Basic methodology of science. Here we want to consider the basic methods and techniques that are applied in investigating the various branches of science that we earlier considered. I mean, physical science, mathematical science, biological science, chemical science, and social science. Even though all these areas, all these branches are different branches of science, the methods that are used in making inquiries, in investigating phenomena which come under each of them, the methods are different. They are not necessarily the same because of the nature of each of the branches of science. And that was why we had to consider each of the branches in the earlier episode. Physical science, what it does with respect to physical issues, mathematical science, biological science, chemical science, and social science. So with respect to the methods and the techniques, we want to start with physical science. Here, first and foremost, we want to explain the legend that we have used so that the description, the chart we have used will not be clumsy. We are using DME to represent direct measurement stroke experiment. EATP to mean axioms, theorems, proofs, and equations. SQ to mean sample stroke questionnaire. So I want to start with physical science. So the basic methods and techniques that are used in physical science revolves around direct measurement stroke experiment. I mean, in the traditional sense. We know that all these fields, they keep on evolving, and sometimes the methods you are going to use will involve one or more of these. But we are just looking at them in the simplest possible form so that we can have a good idea of what the methods are. So physical science, traditionally, you measure and you carry out experiment on what you want to study. Of course, the physical science talks about physical things, things we can feel, we can touch. In the last episode, we talked about physical sciences. We talk of physics and geology are two basic components of physical science. So in physical science, you use measurement and experiment. Of course, it doesn't preclude the use of other methods. For mathematical science is predicated on axioms, theorems, proofs, and equations. So in mathematical science, what you just need to do, you set up axioms. The axioms are self-evident truths. Okay? Like saying 1 is 1, 2 is 2. Then you now formulate theorems based on the axioms. If you have 1, we say that 1 is less than 2, 2 is less than 3, then I can talk about 1 plus 2, 2 plus 3, and so on and so forth. Then the proofs. The proof involve establishing consistent procedure for justifying the theorems that you have stated. Of course, instead of theorems, we have some synonyms which are not necessarily exactly the same. You can call lemmas, you talk about propositions, and sometimes you use the word conjecture. Okay? So the proofs are based on theorems, the theorems are based on axioms. So the proofs are like the theoretical way of proving an experiment, that an experiment is valid or is not valid. As long as your proof is consistent and based on the rules and principles of mathematics, whatever you arrive at using mathematical theorems and proof can always be justified when you perform an experiment. And that is why the beauty in mathematics, sometimes scientists who are working in areas that are not necessarily mathematical, when they get into some difficult areas, difficult problems, they just use the knowledge, the techniques of mathematics to establish the fact. And there have even been many instances in which some things have been proved, some facts have been proved mathematically, and it took a long time before the experimental versions were justified. We can talk about the theory of relativity, for instance, what about Einstein, the general theory and the special theory of relativity. But we don't want to go too far from the discussion. So mathematical science based on axioms, theorems, proofs, and equations. Then biological science, we explain what biological science is. We talk about the various branches, traditional branches of biological science in the last episode, and not only biology, of all these areas of science. So please, if you missed the last episode, kindly go and listen and watch the episode so that you can have an understanding, because whatever we are treating is normally based on what we have treated before. And we have tried as much as possible, we try as much as possible to simplify what we present. So biological science is also based on direct measurement and experiment. Ditto, chemical science is based traditionally on direct measurement and experiment. You get all your equipment ready, and you get your the samples that you want to use to measure, and then you carry out the experiment, you observe, and then you have your results. So in general, whatever you arrive at, as I've said earlier, using direct measurement and experiment should correlate with the theoretical approach, with the results you arrive at when you use mathematical scientific method. Then social science is the method of social science is actually based primarily on samples and questionnaire, because social science measures the behavior of human beings per se. So what you need to do is to have some level of, establish some level of certainty that whatever you have done is valid. So you take some sample, you have a large population, and then you pick some samples, you distribute questionnaire. Of course, I just mentioned questionnaire, it could be interview, and then you follow some basic procedure, give out the questionnaire, people will fill, and then you use some principles to justify that what you have received from the field is actually valid, and then you analyze, and then you are going to bring out the result subject to some level of significance, and so on and so forth. Then we now move to the general tools of scientific analysis. Please take note that in our discussion of science, we actually omitted the engineering, which is an applied form of science. But shortly, we are going to mention that so that we can incorporate technology and engineering into science, because actually technology and engineering emerge from science. The need to specialize in more and bring out some more applied phenomena out of basic science. So general tools of scientific analysis. So in general, when you talk about science, Remember, our target is the laws of science, but the laws are based on these simplifications that we are first presenting. Because by the time we introduce the laws, it will be clear how the laws come about, which area of science is bringing out the laws, and so on and so forth. So that's why it is good for us to have understanding of the scientific principles generally. So for general tools of scientific analysis, you can use statistics. Okay? I mean, having gathered, for instance, in social science, having gathered your result, you have given your data, then you want to analyze it, your data. Maybe you gave out data, 50% or 20% gave yes, 30% said no, some did not return, and so on and so forth. You can use statistics principle. There are so many things, correlation, coefficient, level of significance, and so on and so forth to analyze. And of course, the statistics that we are talking about, you can still use in all the other areas of science. Then mathematical models, just like we said here, mathematics based on axioms, theorems, proof, and as a result of that, you can develop models for phenomena in other areas of science that are insolvable, or they are difficult to solve, or they are presenting some challenges. So the models will help you to see how things could be, and then you can analyze the models, and then you can use that to get the results that you want. Of course, you can use software, which is you use computer programming language to solve the problem, to take the input, to process it, and to have the output. Of course, you can use several programming languages available that including the popular high-level programming languages, Python, Java, and so on and so forth. So any programming language will actually suffice. So everything depends on the person that is carrying out the analysis. Then we can talk about some foundational areas of physics. We know that physics is a physical science field, and when we are talking of the laws of nature, physical laws of nature, in majority of the cases, many of the cases will be referring to the laws of physics, because the physics that describe the physical phenomena per se. So it is good for us to have more understanding of what physics is as a field. So when you talk about physics, you can look at the following as the foundation areas. Of course, please take note, it is a simplified form. These days, you have many specialized areas of physics, but this is the level that we can look at. All these specialized areas, radiation physics, atomic physics, theoretical physics, mathematical physics, and so on, they arose from this place. So this is the foundation. So we decided to use this because this is the basis. So we can talk about mechanics. When you talk of mechanics, you are talking about the physics of motion. The physics of motion. And when you talk about motion, you can talk about statics or dynamics. You can talk about an object that is stationary, and then you want to talk about the forces that are operating on that object that is stationary. Then you can talk about dynamics. When a body is moving, is in motion, what are the forces that are operating on the body? You have, for instance, aeroplane, for instance, vehicles, motor cars, tricycle, and so on and so forth, or just an object. Later, we will see that Newton's laws of motion are very, very significant in mechanics, and they form one of the basic laws of nature, of science. So, and when you talk about the object, you can talk about solid. The object can be solid, it can be liquid, it can be gas. So, mechanics deals with all this. Then we can talk about electricity, and we decided to just include optics and magnetism to be under that. The issue of generating power, generating light, and so on and so forth. That comes under electricity. Also, the laws of science that we'll be considering in subsequent episodes will involve some laws in electricity, like the Faraday's law, very, very important law of electricity. Then we can also talk about heat as a foundational area of physics. In this area, you are talking of anything that's going to generate heat, radiation, that you are going to feel the effects. That maybe, for instance, when you have water, you boil it on your stove, it's going to, and you touch the stove, you feel the heat. That is a simple way of explaining heat. Or you are in an enclosure and there is no refrigeration, no air conditioning equipment, or no fan, then your body feels heat. You feel hot, and then you can talk about heat. And that is why you can use temperature to measure the body temperature, the heat, and so on and so forth. Then, of course, sound is also a foundational area of physics, and we have also included fixed waves as part of it. Because when you have sound, when you talk about sound, sound can be described in terms of waves. If somebody is at a location A, and then another person at a location B far away, and then somebody talks, and you can hear the person at that location, you talk from A, the person in B hears you, it's because the waves operated and transferred what the person at the point A spoke to the person at point B. That is the simplified way to put it. So we have the physics of sound, very, very detailed, elaborate on its own. Then we can also talk about nuclear/atomic physics. Okay, that one relates to, we all know about nuclear energy, which you can also use to generate power. So that area of physics that leads to that is atomic and nuclear physics. When you talk about a particle and the constituent of a particle and how you can manipulate the particles in such a way that there can be fusion, there can be fission, and so on and so forth. And then, of course, you can talk of radioactivity too, and which is also a very powerful tool that has been used to date objects that are thousands and million years old. With the tools of radioactivity, the ages of such objects can be determined, and scientists have applied that principle to determine the ages of so many things, of rocks, of objects, of dead bodies, of preserved bodies, and so on and so forth. The last but not the least, you can talk about astronomy, which in simple terms is the physics of heavenly objects, the solar system, the sun, the moon, the stars, the planets, all of them are structures on their own. So astronomy talks about that. Then we can now move to traditional technology as applied science. Remember here, and in our preceding discussions, when we were talking about science, we didn't actually include engineering, but we just felt it is good for us to add it so that we can see engineering and technology as applied areas of science. For instance, when you talk about electronics engineering, it evolved from physics. After physicists were involved in study of electricity, and then later people started to specialize in electricity, then that evolved when you can use electricity to bring out devices, to power places, and so on and so forth. So you now have the first one we want to call electrical to electronics engineering. Just like we said, it's just an offshoot of electricity in physics. Of course, you have chemical engineering also, which you can trace. Of course, we just say electricity because within it, or some other areas also come in, but we are just trying to identify the key areas in each of them. Chemical engineering, of course, we can say we can trace it from chemistry, the need to develop devices, apply phenomena from basic knowledge of chemistry. Then you can talk about mechanical engineering. Of course, that one also evolved from mechanics and heat. So that evolved from that, and that the mechanical engineering is an applied form of physics of mechanics, physics of heat, and so on. Then we can talk about civil building engineering. Mechanics is also very relevant there, and of course some other areas. And then you can talk about agricultural engineering, in which biological science plays an important role, especially agricultural science. So we want to see how you can use the knowledge of engineering to drive agricultural processes, mechanization, and so on and so forth. So technology engineering is actually an applied form of science. Then we want to look at some other areas. This is just a simplified form. Of course, these days you have so many areas of engineering within the same field, so many others are coming up. So, but we are talking about the traditional areas, so that we can just look at that. And then we just felt we should include some other areas of technology engineering that we have not mentioned here. Of course, there are so many. Of course, we cannot list all of them. So we can talk about aeronautical engineering. This one deals mainly with, aircraft and bodies that are in motion in the sky. So it's an aspect of mechanical engineering, but where you talk about things that are floating in the air, unlike mechanical engineering per se, which in most cases mainly deals with what is moving on the ground. Then we can talk about mechatronics engineering, which is actually a combination of mechanical engineering and electrical engineering. It's also one of the new areas of engineering in which it was just felt that many phenomena in nature requires both the knowledge of mechanical engineering and electronics engineering. Instead of calling two technical persons, calling one mechanical engineer and electronics engineer, why not train a single person to have the basic understanding of both? So that's why you have mechatronics engineering. And some universities now offer this as a degree program on its own. Then you can talk about computer engineering, of course, which also evolved from electronics engineering. And this one deals mainly with the engineering of computer systems, unlike electrical electronics engineering, which is very, very wide, just deals with, all objects that have, you have electrical parts in it. And of course, in virtually any modern day equipment, device that you are going to have something that has some links with electronics. Then you can talk about biomedical engineering, as the name implies, biomedical. That you can see that you can trace it to biological sciences and medical sciences. So it's more or less that the engineering of biomedical processes where you can, design, construct, you can test equipment that will be useful in biomedical applications in hospitals or resolving issues relating to biology and medicine. And then we have here systems engineering, which is also an emerging area of engineering in which the focus is on systems generally. Of course, virtually all these engineering fields, they have systems. But systems engineering looks at the engineering processes as a system. Then you can talk about marine engineering, which is engineering of objects inside water. So it's the focus is on objects, machines that move inside water, just like aeronautical engineering focuses on machines that move in the air. And last but not the least, we have oil and gas engineering, which also deals with issues relating to drilling, oil and gas prospecting. Initially, when you talk about oil and gas, you can link that with the geology, which is inside physical science. But there was a need now to have a specialized engineering area, to have an engineering field to deal with oil and gas. Of course, you also have petroleum engineering, which is more or less like oil and gas engineering, but some institutions study petroleum engineering. They may study it separately. Some may mix petroleum engineering and chemical engineering, or they may subsume petroleum engineering inside of chemical engineering. So it depends, and it depends on the focus of any institution that is offering all these various fields, and it depends on the target, their vision, and the mission. We believe you have enjoyed today's episode, where we look at some basic facts related to the laws of science. We believe that you will stay tuned for the next episode, where we are going to now look at the laws of science in view of what we have considered today with respect to the various branches of physics, mechanics, and so on and so forth. We believe that it is better for us to have considered all the various components of science, the methodology, the tools, before we go into the consideration of the laws of science proper. Thank you for staying tuned. We hope to see you in the next episode. You are welcome.